Hello everyone. So in this class I am going to solve another problem by using Fourier transformation method. Okay, so in this class I will consider semi-infinite domain. So okay, look here. So here the problem is find the solution of the equation k into second order derivative of u with respect to x is equals to derivative of u with respect to t. Here x lies between 0 to infinity and t greater than or equals to 0 when subjected to the boundary conditions. So u tends to 0 and derivative of u with respect to x tends to 0 as x tends to infinity. So and u of 0 comma t is equals to u naught, that means constant, and the initial condition u of x comma 0 is equals to 0. Okay, this is the given problem. Okay, now so here we solve this equation. Okay, let's start to find the solution. So first we consider the given equation k into second order derivative of u with respect to x is equals to derivative of u with respect to t. Okay, here we consider the semi-infinite domain. So for that one, here I'm going to consider the finite sign transformation. Okay, so now apply the finite sign transformation on both sides of this equation. Now observe here finite sign transformation of derivative of u with respect to t equals so k into finite sign transformation of second order derivative of u with respect to x. Okay, so ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ ಸೈನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ನಾವು ಯಾವ ರೀತಿ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದು ನಿಮಗೆ ಗೊತ್ತಾಗಿದೆ. ಓಕೆನಾ, ಸೊ ನಾನು ಆಲ್ರೆಡಿ ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸಲ್ಲಿ ಬೇಸಿಕ್ಸ್ ಅಷ್ಟನ್ನು ಕೂಡ ಹೇಳಿದ್ದೀನಿ. ಓಕೆ, ನಾವು ಅಬ್ಸರ್ವ್ ಹಿಯರ್. ಸೊ ಎಲ್ ಎಚ್ ಎಸ್ ವ್ಯಾಲ್ಯೂಗೆ ನಾವು ಫೈನೈಟ್ ಸೈನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಸೊ derivative of capital U sign transformation. Okay, Fourier sign transformation na apply madidre we get derivative of capital U with respect to t, which is equals to, so right hand side value enagutte square root of 2 divided by pi integration from 0 to infinity k into second order derivative of U with respect to x into sin alpha x into dx. Okay, now integrating this term, so we get, so RHS value will becomes k into, so this is constant, take it outside, so remaining is square root of 2 by pi. So now integrating this term, so we get sin alpha x into, so integration of means integration of this one we get derivative of u with respect to x. So here the limits 0 to infinity minus integration from 0 to infinity integrated term into differentiation of this one. Okay, we get alpha into cos alpha x into dx. Now here we apply the limits. So by using the boundary condition we know that whenever x tends to infinity then the function u and derivative of that function will becomes 0. Okay, so now we apply that boundary condition to this equation, hence this term gets 0. Again we apply this limit, sin 0 means, so this term is also 0. So then the remaining is, so here minus is there, minus k into square root of 2 over pi into, again integrating this term, so we get cos alpha x into, so integration of this one we get u of x comma t, here the limits 0 to infinity minus integration from 0 to infinity integrated term u of x comma t and differentiation of this one, so we get, so minus alpha into sin alpha x into dx. Okay, again here also we apply the boundary conditions, whenever x tends to infinity, so in that time u and the derivative of u, the term that functions is 0. So and here the limit, so lower limit is 0 is there, so we know the boundary condition u of 0 comma t value is u of 0 comma t. Okay, so apply this condition, so upper limit ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಮಗೆ ಈ ಟರ್ಮ್ 0 ಆಗುತ್ತೆ. ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ x tends to infinity ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ u tends to 0 ಇದೆ. ಹಾಗೆಯೇ ಸೊ ಲೋಯರ್ ಲಿಮಿಟ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಮಗೆ ಇಲ್ಲಿ ನೋಡಿ ಬೌಂಡ್ರಿ ಕಂಡೀಷನ್ಸ್ ಅಲ್ಲಿ ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ. ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಬೌಂಡ್ರಿ ಕಂಡೀಷನ್ ಅಲ್ಲಿ, ಇಲ್ಲಿ ನೋಡಿ u of 0 comma t is equals to u naught ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆನಾ, ನಾವಿಲ್ಲಿ ಲೋಯರ್ ಲಿಮಿಟ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನನಗೆ ಏನು ಸಿಗುತ್ತೆ, ಮೈನಸ್, ಸೊ u of 0 comma t ಇದೆ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್, ಸೊ ಆ ಒಂದು ಫಂಕ್ಷನ್ ನಾನು ಅದೇ ರೀತಿ ಲೋಯರ್ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನನಗೇನು ಬರುತ್ತೆ, ಕಾಸ್ 0 ವ್ಯಾಲ್ಯೂ 1 ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಹಾಗಾಗಿ ಮೈನಸ್ u of 0 comma t ಪ್ಲಸ್ ಇಲ್ಲಿ ನೋಡಿ ಮೈನಸ್ ಇಂಟು ಮೈನಸ್ ಇದೆ, ಪ್ಲಸ್ ಆಲ್ಫಾನ ಔಟ್ಸೈಡ್ ತಗೊಂಡಿದ್ದೀನಿ, ಸೊ ದಿಂದ ರಿಮೈನಿಂಗ್ ಇಂಟಿಗ್ರೇಷನ್ ಫ್ರಮ್ 0 to infinity sin alpha x into u of x comma t, this is t. Okay, this is also t into dx. Now look here, so here minus into minus, so minus na ಆಗೆ ಇಟ್ಕೊಳ್ಳಿ, ತೊಂದರೆ ಇಲ್ಲ. ನೆಕ್ಸ್ಟ್ ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೋತೀರಾ ಅಂದ್ರೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಳ್ಬಹುದು. ಬೈ ಯೂಸಿಂಗ್ ದ ಬೌಂಡರಿ ಕಂಡೀಷನ್ u of 0 comma t can be represented as minus u naught. Okay, so now observe here minus k alpha into, so this one into minus u naught. So again ಇಲ್ಲಿ ನೋಡಿ ಮೈನಸ್ ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಮೈನಸ್ k into alpha ಇದೆ, alpha square. Okay, so ಇಲ್ಲಿ ನೋಡಿ square root of 2 by pi into this one ನಾನು ಏನಂತ ಬರೀಬಹುದು, u of alpha comma t ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರ್ದಿದ್ದೀನಿ. Okay, u of alpha comma t ಆಯ್ತು. So again multiplying this one we get plus k alpha u naught into square root of 2 divided by square root of pi. ಇಲ್ಲಿ ನೋಡಿ minus k alpha square into u of alpha comma t. Okay, now so this equation can also be represented as, so derivative of capital U with respect to t plus k alpha square into u of alpha comma t. So now we take this to left hand side, so we get this positive sign, so which is equals to k alpha into u naught square root of 2 over pi. Now observe here, this is the non-homogeneous equation. So here we find the solution. First we find out the integrated factor. So integration factor is, so in exponential of integration of a of t into dt, which is equals to exponential of integration of, here a of t is k into alpha square into dt. So integrating this one we get exponential k alpha square into t. Therefore we get the solution as us of alpha comma t is equals to exponential of minus k alpha square into t into integration of exponential of k alpha square into t into, so this function b of x k alpha u naught into square root of 2 by pi into dt plus c over integration factor. So adana numerator tagondre c into exponential of minus k alpha square into t. Okay, now so integrating this one, so we get, now observe here, so k and alpha is constant and u naught and this is constant term, we take it outside of the integration. So now, so this into exponential of minus k alpha square into t. So again e term na with respect to t integrate madidre we get exponential of k alpha square t over k into alpha square plus c into exponential of minus k alpha square into t. So on simplifying this equation, so then we get us of alpha comma t is equals to u naught over alpha into square root of 2 by pi plus c into exponential of minus k alpha square into t. Now we call this as equation number star. Now in the next step we are applying the Fourier sine transformation of the on both sides of the given initial condition. Initial condition ge ನಾವು so Fourier sine transformation apply ಮಾಡಿದ್ರೆ we get u of alpha comma 0 is equals to 0. Now using this initial condition to equation star, so then we get, observe here, apply this initial condition to equation star ನೋಡಿ, so LHS value 0 ಆಯ್ತು, which is equals to ಇಲ್ಲಿ t value 0 ಇದೆ. So t value 0 ಅಂತ ಆಯ್ತು ಅಂದ್ರೆ exponential value ಏನಾಗುತ್ತೆ 1 ಆಗುತ್ತೆ. So then the remaining is u naught over alpha into square root of 2 over pi plus c. Hence c value is minus u naught over alpha into square root of 2 over pi. Now substituting this c value in equation star, then equation star will becomes, look here, us of alpha comma t is equals to u naught over alpha into square root of 2 by pi minus u naught over alpha into square root of 2 by pi into exponential of minus k alpha square into t. Okay, here u naught over alpha into square root of 2 by pi is common, take it outside, then the remaining is 1 minus exponential of minus k alpha square into t. Okay, now applying the inverse Fourier sine transformation on both sides of this equation, so then we get, now look here, so we apply the inverse Fourier transformation on both sides of this equation, so we get the solution, required solution as, observe here. So here in the RHS we apply the inverse Fourier transformation. So this equation will become square root of 2 by pi integration from 0 to infinity sine alpha x into u naught over alpha into square root of 2 by pi into 1 minus exponential of minus k alpha square into t into d alpha. Okay, now so in left hand side will becomes, so when we apply the inverse Fourier transformation to left hand side, then we get the required solution u of x comma t, which is equals to, so here we take the constant terms to outside of the integration, so we get 2 into u naught over pi into integration from 0 to infinity sine alpha x into 1 minus exponential of minus k alpha square into t over alpha into d alpha. Okay, so this is the required solution for the given partial differential equation. Okay, so this is your solution. So in this problem here we consider the semi-infinite domain. Okay, so in the next class I am going to solve another problem by using Fourier transformation method. Okay, thank you.